Into the video, um, we're working on the King contract on Ethernaut. Um, the purpose of this challenge is to essentially prevent anyone else from becoming the new king. So we have a few things. We have a king address, we have a prize pool or a prize, and then we have an owner of the contract. And the idea is we want to become the king of this contract and prevent anyone else from becoming the new king. And this is essentially a typical Ponzi scheme contract where the person who deposits the most money will receive the previous deposit's prize. So how it works is you send money to this contract. If you are the owner or you send ethers that's greater than the prize, you become the new king and you get paid the message value of what you sent. So payable king.transfer. Yes, you get paid the message value of what you sent. Then next, you become the king, and then the prize. This becomes the new prize. So that's how this contract works. Whenever you go to submit it, Ethernaut is going to try to proclaim kingship. So they're going to try to become the new king. And while they are the owner and they can easily call this receive function, this should reject because the current king in standing will essentially deny this transaction. And that's what I'm working on right now. I'm going to try to create a king that's not going to be able to accept ethers. So right now we're testing out this theory. We set up a quick attack deploy script. So we are going to first so first I'm going to deploy a contract and just make sure that that reverts every time I try to send it some money. So we're going to run this script here. And it looks like it didn't work. No, so it didn't work. So this did not work. Confirm exploit did not work. Okay. So I'm probably losing money because I'm over here deploying a contract, but let's say gas limit. And I don't know why I have to do this every single time, but I have to do a manual gas limit here. And usually this helps pass it, but let's see. So right now it's deploying a contract. Oh. Insufficient funds. I should have 0.001 ETH, so that shouldn't be a problem. So I didn't have enough funds for the transaction costs. So let's do something for a second. Let's view on Etherscan and see if we could figure out this issue. So it doesn't show that transaction actually occurring. Exceeds block gas limit. Exceeds block gas limit. Interesting. So I'm able to create the contract. That's all good. Maybe that's it. Maybe I had the gas limit too high. All right. So we should have successfully had a rejected transaction. So let's go back here. Contract creation. Not sure why I didn't show the transaction. Oh, okay, here we go. So yes, transfer 0.01 ETH was and execution reverted. All right. So that's what we need. We know that we cannot send ethers to our contract, right? So this is a good like proof of concept that our exploit should work. The homie just texted me. Yeah. Okay. So yeah, we know that this is going to fail. And so we don't need to test this anymore, honestly, because we know it's going to fail now. So we know that that piece works. But let me keep that. What we want to do is we want to expect the, do we have king? Let's expect the king. Take this out. Now let's actually leave that. This is crucial for testing. So we're going to expect the king to equal to attacker dot address. Sorry, no. Attacker contract dot address, right? Because our our attack contract should be the new king. So we're going to grab the price data. And let's actually not deploy this. Let's do one more thing. Let's grab the price data, or the prize data. We're going to, and king data. Let old king equals await king contract dot king. And let's just see who this is. The old king is old king, and this should be Ethernaut owner. So to be equal to attacker contract, it should be king. Actually, I don't even know who the owner of that is. So let's just comment this out for now and run this without deploying anything new. Attacker contract. We didn't deploy that. It's not a function. It's underscore king. You got me. Okay, so this is going to be the old king, and that's going to change to the contract address. So, let's make, do a few things. We're going to deploy our attacker contract, make sure that's deployed. And then we want to invoke our attack function with the prize value to become the king. So let transaction attack equals attacker contract dot attack, right? Calling this attack function. And I should remember how to do this, but the value is going to be equal to ethers.parse or ethers.utils.parse ether, and we're going to send prize value in ETH. And I believe that's how we do it in Hardhat. Let me call a function. Or at least when we call a function with a value. So we go to home. Let's just say calling a function in Hardhat. I literally always search this up. But yeah, you do it inside of the message or the function. So we have this king. So we're going to parse ether. It's going to be that prize value in ETH, because remember, if we send the prize value, if our value is greater than or equal to the prize, then we're going to successfully invoke this receive function. And so what we're doing is attack is going to send the 0.001 ETH to this contract, which should invoke the receive. So we're going to see. It may fail. There may be a reason with why this fails, but this should be the case. So parse ether is going to send that 0.01. Don't need that, but we need a receipt. So let transaction receipt equals transaction attack dot wait and the transaction attack receipt is this here. We're going to look at that transaction receipt. So we want to know what happened during that transaction. And then, actually, okay, let's grab the transaction too. So we're going to invoke our attack function, and also we have to make sure we call await because it's an async function call. There's no need for any type of self-destruct or anything, but for point number 3, or our third part, is we want to grab the new king contract, or sorry, the new king. Okay. Excuse me. All right. King is going to be equal to await king contract dot king. The new king is excuse me. Excuse me. All right. This should be our attacker contract address. And just to verify, or actually no, we'll do this in our check here. Check if our contract is new king. We're going to say expect the king to be the attacker contract address. And if this test passes, then we know we have a successful exploit, because our attacker contract address cannot receive any ETH at all via a transfer function, and we know this because we actually just tried to transfer, and we confirmed it on Etherscan. So let us try and commit this full exploit. Let's rerun through this because sometimes we make mistakes. So we have king exploit using attack contract. We have a setup for attack. So first we want to get an attacker address. We don't really need this, but I just keep it in my templates. The contract address, this is the address of the deployed. This is the address of the deployed king contract right here. We're going to deploy our own attacker contract, which is going to commit the attack. Then we're going to make sure it's deployed. And then we're going to grab our king contract. We're going to begin our exploit. So let's grab this price, or the prize. We're going to make sure we convert that to a value in ETH, so that whenever we send the transaction, we'll know how much we need to send exactly to start this exploit. Then we're going to invoke our own attack function. So what this is going to do is send 0.001 ETH to our attack contract, which is then going to send this 0.001 ETH to the king address. Okay. And what's going to happen is it's going to invoke this receive, and it should become the new king. All right. We're going to wait for this transaction. We'll print this out just so we can see some details about that transaction. And then next, we're going to grab the new king and log it to the console. So this should be the deployed contract address. And to verify, we can say log to the console, and log the attacker contract to the console. Just so that we can see, like this test is going to verify that, you know, our new king address is equal to our attacker contract address, but we want to just go ahead and see that ourselves. The attacker contract address is, and let's say attacker contract dot address. All right. This is just so that we know, we see this. So I think this exploit should work. We're going to see if we run into any issues. Maybe we've forgotten a weight somewhere right here. Yeah, this is looking good. Let's go ahead and run this exploit. Let's watch it live. Okay, the old king is this. Next, we're going to make that transaction. Nice. The new king is this, and the attacker contract is this, so they became the new king. All right, so let's look at a few things. This is the transaction hash of the attack. We can go look at this on Etherscan. It went from my address to the attacker contract. This data should be the function that we invoked, so we could actually look at that because Solidity Visual Developer has a good way to see these. So let's look at the function signature. Yep. 9E5FAAFC. So that's the function we invoked. We know that. We don't really need to care about this, but so what happened? So we sent money to this address. This is just the logs, the block hash, the transaction hash, which should match here. B6, yep. Okay, and this is just the receipt. So confirmations, one confirmation, how much gas was spent, the whole nine. So we should have successfully completed this. Now the part of the actual, make sure this exploit works is submitting on Ethernaut. So when we submit this instance, what they're going to try to do is take back King's ship. And what's going to happen is they're not going to be able to, because we successfully made a contract that blocks any transfers. So that's the theoretical problem. If they are able to take King's ship, then we're going to have to approach a new attack tomorrow. Submitting. Mine the transaction. Let's go. All right. So we successfully performed this exploit. And it is 9 o'clock. So I'm going to do some other studying on my own. But this is a great example of learning how kind of contracts work. You understand what happens when you transfer money to contracts, and then also you understand how do you prevent transfers from occurring in your contract. So we're going to go to the next level. We can do the next one tomorrow. Reentrancy, it's a prominent vulnerability we'll see in a lot of contracts. I'm very excited for this one because I think this is going to be a tough one for me. But yeah, we'll tune in either tomorrow or sometime this week to do this one. As always, feel free to DM me on Twitter or on Telegram if you have any questions about any of these challenges, or just drop your comments in the video. Thanks, y'all.